This whole part of our planet has disappeared. It used to be a tectonic plate, but something that big doesn't just vanish without a trace. And the clues that led to its discovery started in this mysterious gap between South China and the island called Borneo. For a long time, people thought the sea between these two places sat on a tectonic plate called Izanagi, which no longer exists. But wait, how does a tectonic plate just vanish like that? Alright, tectonic plates are like pieces of a puzzle all connected together. But instead of sitting on a table, they're floating on this semi-fluid layer. So they're always shifting and bumping into each other. And there's something else. Some pieces of this puzzle are heavier than others. And what happens is that eventually, a heavier piece slips under a lighter one. Something similar happens with tectonic plates, but it's less about weight and more about density. When the edge of one plate sinks below another and gets pushed down into the mantle, that process is called subduction. But it's not just the edge that can sink. Entire massive plates from the past have completely vanished into the Earth's mantle. That's exactly what happened to the Izanagi plate. About 130 million years ago, it started sliding under the Okhotsk plate, getting swallowed little by little. By around 55 million years ago, it was completely subducted and replaced by the Pacific plate. And for years, specialists thought that the ocean between China and Borneo was sitting on that plate before it disappeared. Cool, but the experts got it wrong. Turns out the ocean between these lands wasn't sitting on the Izanagi plate after all. Instead, it fits into this weird, unexplained gap, as if a piece of the puzzle was missing. Recently, researchers at Utrecht University finally discovered that this gap was actually a ghost tectonic plate that no one knew about, the Pontis Plate. It got its name because back when it existed, it sat beneath the ancient Pontus Ocean. But if it vanished so long ago, how did experts find it, right? Luckily, tectonic plates sometimes leave traces before they completely disappear. But instead of investigating footprints or fingerprints, it's more about looking for rocks. Yeah, stones from a lost plate can get incorporated into mountain ranges and show us where those ancient Earth layers were. That's because rocks have a special power to record Earth's magnetic field. You know, that invisible shield that protects our planet from space threats, like solar wind and cosmic rays? So, as rocks cool and solidify, the magnetic materials in them, like magnetite or hematite, line up with Earth's magnetic field at the time and get locked in. They can freeze a record of the magnetic field direction and strength. And since it changes depending on latitude, basically whether it's further north or south on the planet, it allows the rocks to kind of take a snapshot of their ancient position relative to the equator. Knowing this, researchers traveled to Borneo to collect and study the rocks over there. And they discovered something odd. These stones were originally from a much farther north region. Their ancient coordinates didn't match the latitude they expected for Izanagi. In fact, they didn't match any of the tectonic plates we knew about up until then. So they quickly realized two things. One, they had just discovered an eerie gap. Two, there must be a hidden ghost tectonic plate that used to be in that spot. To unravel the mystery, scientists used computer models to study the region's geology over the last 160 million years. Thanks to this technology, they were able to piece together the entire Pontis Plate in all its glory. The next step was to figure out the key features of this part of our planet that had been submerged, like its age. You see, the rock samples collected in Borneo date back 135 million years, back when dinosaurs ruled the Earth. With this information, scientists realized that the Pontis Plate was formed at least 160 million years ago, but it's probably even older than that. Although it is hard to pin down exactly when it was formed, one thing we can say for sure: it was huge. The Pontis Plate was about 1/4 the size of the Pacific Ocean. Unfortunately, by around 20 million years ago, it said bye-bye to the planet, sinking and being completely pushed under the Australian Plate to the south and China to the north. At this point, you might be wondering if a couple of rocks and a computer reconstruction are enough to prove that the Pontis Plate really existed. Well, yeah, they are. But other clues have also been found in Palawan, an island in the western Philippines and in the South China Sea. The truth is that the scientific community has suspected the existence of Pontis for over 10 years. At that time, researchers were really focused on the area around the Philippines. This region is like a playground for geologists, since it sits at the crossroads of several tectonic plate systems. So, scientists decided to reconstruct the movements of the Earth's crust between Japan and New Zealand. And because of that, the study suggested there had to be a subduction zone running through there, separating the known Pacific plates in the east from the hypothetical Pontis Plate in the west. These previous predictions were possible because tectonic plates are really bad at playing hide-and-seek. Like we said before they get submerged, they leave clues behind. And it's not just rocks. They can also change the Earth's mantle, which leads to the formation of volcanoes, earthquakes, and deep ocean trenches, for example. But the subduction process can also mess with the composition and temperature of the mantle, making some areas hotter or cooler. These are considered anomalies. It is possible to detect these anomalies using seismographs, which are instruments that pick up earthquake signals and record the ground's motion. When earthquakes happen, they send out ripples or waves through the Earth. These waves travel through the Earth's layers, but if they hit something unusual like an ancient piece of a tectonic plate hidden in the mantle, the waves get disrupted. It's like hitting a bump on a smooth road. It messes with the ride. Using regular seismometers to look for anomalies is fine, and it can totally help us find clues about the Earth's past. But if scientists want to use this method to get pictures of what's really going on beneath the surface, it gets a lot trickier. Not only do the images come out in low resolution, but the process also becomes insanely expensive. So recently, experts just uncovered a cutting-edge technique that could completely change the way we look at the Earth's depths. Kind of like an ultrasound, scientists can now actually see what's happening miles beneath our feet. More specifically, in a region between the Earth's brittle crust and the mantle underneath, known as the MOHO. This new method is called Distributed Acoustic Sensing, or DAS. It uses fiber optic cables, the same ones that give us high-speed internet, as earthquake sensors. Here's how it works. Laser beams are sent through the cables, and when the ground moves, whether from an earthquake, traffic, or other vibrations, the shaking changes how the laser light bounces around inside the cables. The cool part is that we can now measure these changes all along the length of the cable, so the cable ends up acting like hundreds of tiny earthquake detectors spread out over a huge area. This new tech can tell us things like whether major faults go all the way into the mantle, how ancient and modern processes have shaped the continents, and how strong the deep crust is in certain areas. In other words, DAS could be a game-changing instrument to help us uncover new clues about hidden and ancient tectonic plates.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.